All right, 8.1. So chapter 8 is all about rational expressions and radical expressions. So we're going to be getting into radicals a little bit later in the chapter, but the first half of the chapter is talking about rational expressions. So what is a rational expression? Well, it's a quotient, which basically means, a ratio or a division of two polynomials. And we did a little bit of this earlier. Back in, I believe, chapter 6, we did long division and synthetic division. For some of these special type of polynomials where they went in there evenly or they had a remainder and we found roots and factors. But these ones we're going to be doing a lot of factoring and a lot of canceling out, and we're actually going to be multiplying and dividing fractions with x's in them. So that's kind of what we're up against. So here's just a few examples of what a rational expression is. They just involve numbers and x's on top and bottom both. So the first three we need to simplify. And then the second part's kind of important here. So it says identify for which the expression is undefined. So remember, when you try to divide using your calculator, anytime you divide a number, and I don't care what it is, maybe a number like 5, if you try to divide it by 0, your calculator gives you an error. So basically, an expression is undefined anytime the denominator is 0. So that's kind of what we got to make sure cannot happen. And then we need to identify or say, hey, these x values are not allowed because they give you a 0 on the bottom and you can't have that. So we'll kind of cross those bridges when we come to them. So let's get started. The first one, it's just a very straight up, there's no pluses or minuses involved. So we're just going to go back to like chapter 1 and use our rules. So 3 over 2 is going to kind of stay there. But then x to the 7th and x to the 4th can be canceled out. These 4 will cancel out with 4 of these. So it's actually going to leave me x to the 3rd on top. So I've simplified the expression. I also could write this as 3 halves x to the 3rd. So this is simplified. But I do need to be aware that on the bottom, so this is kind of that undefined part. Well, when is 2x to the 4th equal to 0? Like, I got to figure that out. This one's not very hard. Divide both sides by 2, and you get x to the 4th equals 0. So x equals 0, we're not solving anything, but we've identified the x value. That's where the function is undefined. So when x equals 0, we really don't have an expression anymore. There's an error. All right, moving on to number 2. Well, if I want to simplify this, what I'm always going to want to try to do first is I want to try to factor it. So on the top, I'm going to try to give myself an expression. Remember how to play the game, 2 numbers that times together to make -3, but then they have to add them together to make -2. So I think x minus 3, or take that back, I think x minus 2, or no, I had it right, x minus 3 and x plus 1. I think that combination right there of -3 and a positive 1, they're going to multiply to make this number. They're going to add to make that number. So I've pretty much wiped out the top. I've rewrote it as factors. And what I'm hoping to have happen is when I do the bottom ones, I'm hoping to have something cancel out. And when I factor out the bottom, I believe I could do a 1 and a 4, x plus 1 and x plus 4. And then look what happens. I have the same exact thing on the top and on the bottom. So I can cancel out the x plus 1s. And that just gives me this expression, x minus 3 over x plus 4. All right. So this is simplified. Can't really break it down any lower than that. But then I also have to realize that my undefined values, so the function is undefined at x equals, well, I can kind of go back to these two factors. If x is -1 or if x is -4, that function is going to be undefined and I'm going to get a 0 on the bottom. So this is kind of the second part of our answer, is identifying where it's undefined. All right, we go on to the next one. This one looks a little bit tougher because I have a coefficient in front here. So you could just try using combinations. I'm going to do the bottoms up method. So remember the bottoms up, this kind of goes back a little bit, but I'm going to multiply by 6 over here. And I'm going to end up having That'll be x squared plus 7x plus 12. And I get my combination. You know, that's going to be, what's that going to be? X plus 4, x plus 3. But then I got to go back and I have to divide by that 6. So I want to divide by the 6. And I need to reduce this down. So bottoms up method, you reduce that. So that's going to be x plus 2/3. And this one's going to be x plus 1/2. Well, since neither of those are whole numbers, I'm going to bring the bottom up. So the bottom's going to come up. And I'm going to have this. And the bottom's going to come up. And I'm going to have that. So I've just factored the top out. The top is going to be 3x plus 2. And then the other one's going to be 2x plus 1. Now, you might be able to just try combinations and get that. I don't know which would be faster. You kind of have to develop your own little skill there. So now I'm going to do the same process, but I'm going to do it for the bottom. So let's do it for the bottom piece. So on the bottom, I'm going to get x squared minus 5x minus 36. So that looks like negative 9, positive 4. And I got to divide by that 6. So I get x minus 3/2. And I get x plus 2/3 when I reduce. Bringing the bottom up, that'll give me 2x minus 3. And then 3x plus 2. And then luckily, what I wanted to have happen, I got a cancellation there. So what I'm left with is 2x plus 1 over 2x minus 3. We are simplified. And looking at the x's that make this thing undefined, well, I can get that from right here. So it looks like we are undefined at x equals positive 3/2 and negative 2/3. Those are going to be my two undefined values. Moving on down to number 4 and number 5. These two are a little bit different. You might want to put a little star beside here because sometimes it's helpful to factor out a negative because I want my x, or I want my x squared positive. So when I look up here on the first one, the very first thing I could do is I could factor out a 2 on the top. But since I see this negative 2x, I'm going to actually factor out a negative 2. So I'm pulling negative 2 out, and I get negative 5 plus x. And then the bottom, I get an x minus 5. Well, it may not look like you can do anything right here, but really if I rewrite this top expression, I can rewrite that as x minus 5. So I end up with negative 2 x minus 5. And then the bottom, x minus 5. And I get a little cancellation there. We get a final answer of just 2. And then we are undefined when x equals 5. Always go back to your original expression when you want to see what was undefined. Not after you've done canceling, but on the very original one. All right. You also, maybe in the very beginning, could have rewrote that top as negative 2x plus 10. And then when you factor the negative 2 out, it would have been a little more straightforward. So that might be helpful. Maybe rearrange it before we even get started. Totally up to you. So on this next one, I'm going to pull out a negative x, which gives me an x minus 3. Yep, because then I'll have negative x squared, positive 3x. And on the bottom, I'm hoping to get an x minus 3. So you maybe could even cheat a little bit. I'm going to factor out this bottom one. You could use bottoms up if you'd like, but you might be able to get away with, well, I know the only way to get 2x squared is 2x and x. And I might be able to get lucky. I mean, since there's only a couple ways to make a positive 3. If they got to multiply to make a positive, add to make a negative, I'm thinking negative 1, negative 3. And since I know this whole section is about canceling, I'm going to kind of go with that. And it looks like it'll work out. That'll give me 2x squared minus 7x plus 3. Yep. So 2x minus 1, x minus 3. These dudes cancel. So I'm down to here. So there's my simplified expression. But again, don't just look at this bottom to find out what's undefined. When you want to do undefined, you got to go back to the very beginning. So when are these two undefined? Well, we're undefined here when x equals 3. And we are undefined here, set it equal to 0. And that'll be 2x equals 1. So it looks like also at x equals 1/2. These are the two x values that the function, they're going to be undefined. If you look at a table on your calculator and you were to punch that in, you know, it's y equals this thing, and you put all that in, when you go to your table, you're going to get an error at x equals 3 and x equals 0.5 in the table. It'll literally say 3 and then error, you know, 1/2 error. So that's what shows up on the graphing calculator. All right, moving right along, let's multiply some rational expressions. But first of all, we got some rules. So number 1 says factor out all the numerators and denominators completely. Then we want to divide out common factors. That way we're not multiplying more than what we have to. Then we actually can multiply the top and the bottom and then make sure that there's no common factors. So let's kind of put this into practice. So, you know, basically what it's saying is I don't want to just blatantly start multiplying the top together and the bottom together. You know, I'm going to get an x squared on top. I'm going to get x cubes on the bottom. It's going to get big and messy. Let's try to whittle it down if we can first. And this kind of goes back to fractions. If you think about multiplying fractions, like, you know, 15 over, I'm just going to kind of make something up here. Let's say 15 over 28 times, oh, I don't know, 14 over 45. Well, if I said, hey, you have to do that by hand, you could multiply the top, multiply the bottom to get two big old numbers and then have to try to whittle that down. The easier way is you can always cross cancel on a bow tie. You can either cross cancel up and down or diagonal as long as you're multiplying fractions. So if I look on diagonals, 5 goes into here 3 times and 5 goes into here 9 times. And actually I could do it again. 15 went into both of them. So 3 goes into itself once. 3 goes into here 3 times. So that could reduce to like 1/3. Well, 14 and 28, 14 goes into itself once and goes into here twice. Now I have a really easy fraction. 1 times 1 and 2 times 3, and it's already reduced for me. That would have been way easier than trying to multiply that first, and then whittling it down. So we're going to do the same type of idea here. So let's factor everything we can. Step 1 is factor. So on the top, there's not much I can do. X plus 2. On the bottom, I can yank a 3 out of there and do x plus 4. Over here, can't do much with the x plus 4, but I can, this is a difference of squares. This is going to be one of those x plus 2, x minus 2. And I recognize that because it was missing the middle term. And now there's a lot I can cancel. You know, I can cancel out this x plus 4 with this x plus 4, this x plus 2, and this x plus 2. So if you notice on top, nothing's there. So there's just going to be 1 up top. There's got to be a placeholder there. Put a 1 there. On bottom, it's just going to be 3 times x minus 2. Now, you might see it like that, or you might see it where they actually distribute it all the way out, and you'll get that expression there. It said assume that all expressions are defined, so we don't have to do the part about when the bottom is 0. So that's kind of nice. We don't have to worry about that part. But factoring is huge. You always want to factor first. Cross cancel those things out, and then you can go ahead and start multiplying if necessary. So on the bottom here, let's clean this up a little bit. Just with the numbers, I see that, you know, 2 goes into itself once. It goes into here 4 times. 3 goes in there once. 3 goes in here 5 times. So I got the coefficients kind of squared away. Over here, these 2 x's cancel out with 2 of those. And if I look at my x's over here, these two are going to wipe out with 2 of those, so there'll still be an x left on bottom. When I look at my y's, these 2 y's cancel out with 2 of those, making it 3. So at the end of the day, I have my coefficients, 1 times 5. I have the x squared, y to the third. Now on the bottom, I believe I just have 1 times 4x. So that's 4x. But then I realize that I have, a square. X is still on top and bottom. So this x is going to cancel out with one of these. So at the end of the day, I have 5x squared, y to the third, all over 4, and we are reduced. Now, there could have been a few different ways to do that. Some people may have found it a little bit easier to maybe just multiply the whole top row and get 30x6, y5. Then on the bottom, get 24x to the 5th. Remember, when you multiply powers, you add the exponents. Y squared. Now you only have to do your canceling once. And so it looks like I must have made a mistake on my first one, because when I do it this way, and I look here, I have a number, 6 goes into both of these, 6 goes into here, 5, 6 goes into here, 4. So I get the same 5/4. But I notice that I have x to the 6 over x to the 5th. That's only going to leave me 1x there. And if I look at my y's, these 2 cancel out with 2 of those. So I must have missed something on my first one when I did some canceling. Not really sure. Let me just kind of go back and peek at that. So these all went away. There were still 2 left there. These 2 canceled with one of those. Oh yeah, so on top there was only x squared. So this 1x would cancel out with that one. Yeah, so there should have just been 1x up on top here when it was all said and done. So a little screw up on my part. Glad I did it the other way, just to double check. All right, now dividing. So remember, when you divide fractions, like just for instance, let's say that you have like 2/3 divided by 1/4. You really don't divide. You change the multiplication, and then you do the reciprocal, or you flip it. So you don't divide, you multiply the reciprocal, or keep, change, flip. So I'm going to do the same exact method here. So I'm going to rewrite this first off as, this is going to be 4x to the third over 9x squared y times the flip over here. Here we go. So a couple different things you could do. If you want to, you could just multiply the top and bottom right now. I think that might be easier than canceling everything separately. So first thing though, the constants, I want to get rid of some of those. So I noticed the 9 cancels with the 9. And I noticed the coefficient here, 4, goes into itself once, goes into here 4 times. So at least I got my coefficients squared away. So on top, 1 times 1 is 1. And then x to the third, y to the 5th. I'm just going to smash those together. Then on bottom, I have 1 times 4, so I have 4. Then I have x squared y. And now we just need to do a little bit of housekeeping, clean this up a little bit. So these 2 are going to cancel with 2 of these, so it's just going to be x to the first. And then this y cancels out with that, and it's going to make it to the 4th. So it looks like I have x, y to the 4th over 4. And that's about as low as we can go. All right, over here to the right, this is a monster. This is a big dog. So hopefully I got enough room. First thing I'm going to do is I'm going to rewrite this. So I'm going to write, actually, I'm going to try to do 2 steps to save space here. I'm going to try to factor everything out, but I'm going to rewrite it as multiplication as we go. So for this one, on the top, I can pull out an x to the third. And I'm going to get x squared minus 4, which I know that can be factored. On bottom, that's going to come out to be an x minus 2 times x plus 1. So if you weren't good at factoring before, you're going to be really good after doing this a lot this chapter. Now I know that I need to multiply, and I need to flip these two. And when I factor this x squared minus 1 here, that's going to be an x plus 1, x minus 1. And the top one, I think the best thing I can do right now is I can yank a GCF of x to the third out. And then I'm going to get an x squared minus x minus 2 right there. So now we got some things we can clean up. So let's move over here. X to the third. That x squared minus 4 is really an x plus 2, x minus 2. And on the bottom, I have an x minus 2, x plus 1. And we're timesing that. The top over here was already done for me. And this thing needs to be worked on. That is an x to the third, and then an x minus 2, x minus 1. Holy smokes, we got a lot of stuff we can get rid of. So let's go through canceling from top and bottom. You know, this can go with that. This can go with that. This can go with that. So all that's left, oh, and then I have an x to the third, can cancel out with an x to the third. So holy smokes, at the end of the day, all I have left is x plus 2 on top of x minus 2. That thing was a doozy. Number 9 was no joke. A lot of factoring, a lot of canceling. All right, last two. We've just been simplifying a whole lot, you know, dividing, multiplying. Now we got to solve something. So you could, you know, one way to do this would be to multiply both sides by x plus 3. Don't write this down. But, you know, you could leave this side like this, multiply the x plus 3 by the other side. Now you have a quadratic to solve, so you move everybody over, and you say, well, x squared minus 7x minus 30 equals 0. To solve a quadratic, you always set it equal to 0. And then you got to start factoring. You know, and you could probably use 3 and 10, and you could get it done. But another way, since we're learning this, instead of going into that, let's try to simplify this expression on the left first before we get all happy trying to solve it. So I have x plus 3, x minus 3, all over x plus 3. Well, the nice thing is these cancel out. So all I really have to solve now is x take away 3 equals 7, which is x equals 10. So a lot of times it's faster to simplify the radical expression first before you start trying to solve it. And you're just going to have a lot less like pieces, and your quadratics are going to be much smaller. Try the same thing over here. So on the top, I'm going to factor this first. I think that's a plus 4 and a minus 1. X plus 4, x minus 1, all over x minus 1 equals 5. Cancel, cancel. So I just have x plus 4 equals 5, which gives me x equals 1. All right, so that right there kind of breaks it down for you. That gives you at least some skills so you can get working on the practice. Good luck. See you.